Hey, Mr. Snyder here. Today we're going to be looking at the first step of being successful when working with fractions, and that first step is to be good at looking at or doing common multiples, okay? So common multiples, let's go ahead and take a look at what I mean by that. So let's start with a problem, okay? So common multiples. Let's look at the numbers 6 and 15. 6 and 15 do have a common multiple, and to be able to do a common multiple, what you have to do, or the most basic way to find a common multiple, is to list out the multiples of both 6 and 15 and kind of see where down the line in each of those multiples where they match up, and that is a common multiple, okay? So 6 and 15, let's start with 6, okay? So 6 itself, when we start looking at 6, the multiples of 6 are 6, 12, what comes after 12? Let's see here. Ooh, I can change color. No, I don't want to do that. Let's see here. 18, 24, 30, I think is next, and then 36. So those are the multiples of 6, and it keeps going, okay? Let's look at the multiples of 15. Now, 15 starts at 15. We take 15, the next multiple of 15 is 30. Ooh, I got a text. Let's look. Nope, that's an email. Screw it. All right, so 15, 30, airplane. Ooh, kidding. All right, so 15, 30, 45, and that keeps going on. Now, what you'll notice is that both 6 and 15, when you're looking at the multiples, match up again at 30, okay? So 30 is the common multiple of 6 and 15. Is there another way to do that? And yes, there is another way to do that. And now I want to show you this cool little trick that I just found out about. In order to find the common multiple a little quicker, what we can do is take 6 and break it down into what's called its prime factors, okay? This process is called prime factorization. To break 6, you have to break down 6 into prime factorization, or its prime factors. You have to think about what times what times what, or just what times what will get me to 6. 6 itself can be actually broken down into the multiplication problem of 2 times 3. You'll notice that both 2 and 3 are prime numbers. What's a prime number? Well, a prime number is a number that's only divisible by 1 and divisible by itself. Notice 2 is only divisible by 1 and divisible by itself, and 3 is divisible by 1 and by itself, okay? So that is the prime factorization of 6. I'm going to do the same thing for 15. 15 gets broken down to 3 times 5, because 3 times 5 is 15. Both 3 and 5 cannot be broken down anymore. The way this trick works, is to list the prime factorization of 6 first, so that's 2 and 3, and then below it lists the prime factorization of 15. So the way we do that is we're going to list out 3 and 5. Now, the trick to this is you're going to want to take anything that matches. For example, both the 6 and the 15, the prime factors, they both share a 3 there. So what I like to do is I like to list that number underneath the 3. So I have a matching pair of 3s for these prime factors. And then I'm going to list the 5. The reason why I don't put the 5 underneath the 2 is because they don't match. The next step to this trick is to just drop down all of the factors. So 2, 3, and 5. I don't list 3 more than once because, again, of that shared factor, okay, that matching factor. So I don't have to list the 3 more than once, okay? Then what you do is you multiply the 2, the 3, the 5 together, and that will tell you what your common multiple is, okay? And you'll see that, yes, 2 times 3 is 6, and then 6 times 5 is 30, and that's what we got already above. So you'll notice this is kind of a quick shortcut, and you might say, well, Mr. Snyder, I could have figured that 30 out a lot quicker doing it the other method, and you're probably right. But when you start messing with bigger numbers, you'll notice that this trick sometimes actually does help out a lot, okay? So let's try another problem here, okay? So let me clear the page, and let's try another problem. All right, so let's go ahead and look at 6 and 8, okay? So 6 and 8. I'm going to show you this trick again to see if we can figure out the common multiples 6 and 8. So let's again start with 6. The the prime factorization of 6 is just 2 times 3, which is what we did before. 8 we haven't done yet, so let's go ahead and try it. Now, when you're starting to do these at first, they are a little tricky. For example, when I think of 8, I think what times what is 8? Well, that's 2 times 4. Problem with 2 times 4 is 4 itself is not a prime factor, meaning that 4 is actually not a prime number because it's divisible by 1, it's divisible by 4, but it's also divisible by 2. You can divide it by 2. Therefore, that's not a prime factor. So you're actually going to have to break this down. Well, how do I break down 4? You have to ask yourself again, well, what times what is 4? And the answer is 2 times 2. So you can break down 4 again. So we get 2 times 2 times 2 is going to give us 8. 2 times 2 times 2 is the prime factorization of 8. So let's go ahead and match these up. So first I want to write the prime factorization of 6. That's 2 and 3. And then let's write the prime factorization of 8. That's 2. I don't put the next 2 here because, again, it doesn't match up with 3, so I'm just going to put it off here to the right. You could also put it off here to the left. It doesn't really matter. But let's put another 2. Let's put another 2. And let's drop these down. Again, if there's a match, you just list the number once. If there's nothing to match it with, you just drop it on down. 2, and then 2, and then 2. All right, so 2 times 3, which is 6, times 2, which is 12, times 2, which is 24. Okay, so the common multiple of 6 and 8 are 24. Okay, you can list out the numbers and our multiples of each and find out that it is still 24. So this works. Okay, this is a kind of cool trick. All right, let's try another one. So let's look at 12. Let's look at 18, and let's look at 30. Can we get the common multiple of not just 2 numbers but 3? Haha. All right, so this is a little bit trickier. Now, when we list out these common multiples, this is the reason why I wanted to show you this trick is you'll notice that 12, 24, 36, and we can keep going, 48, blah, 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 blah. Let's do 18, 18, 36. All right, ooh, it looks like we got a match at 36. Let's do 30s. We got 30, and then 60. Oh, we blew right past 36. So you know what? We're going to have to keep going. Problem is, we're just going to have to keep going a lot for each of these. And when you have 3 numbers, that could just be kind of tedious and kind of annoying. Sad, frowny face. So, you know what? That method just is going to, that just stinks. Let's try this other method we learned, okay? So let's go ahead and look at 12. Prime factorization of 12 is just going to be 4 times 3. Crap, 4 can be broken down. So let's break that down to 2 times 2 times 3. That is all 3 of those numbers are all prime factors, so that is it. Let's look at the next one. Let's see here, 18. 18 can be broken down to, let's say, 6 times 3. Oop, 6 can be broken down some more. 2 times 3 times 3. Okay, so there's the prime factorization of 18. Let's look at that last one, which is 30. 30 is just going to be, let's see here, 15 times 2. Well, let's break down 15. That's 3 times 5 times 2. Okay, so there's the prime factorization of 30. Okay, let's put it all together. So starting here, we got 2, 2, and 3. That comes from the 12. Below that, we're going to match up one of the pairs of 2s and another pair of 3s. We have an extra 3, so that kind of gets its own slot. Let's look at 3, 5, and 2. There's a 2 that matches up, so we can match up with one of the pairs of 2s. There's a 3 that matches up, and then finally 5 gets its own slot. Let's drop down all of these numbers. So we got 2 here. We got one thing of 2s, okay? Again, you don't have to write every single one, it's just a match, so we just have to list just that match. Then 3, and then 3, and then 5, okay? Now, we need to multiply this together, 2 times 2 times 3 times 3 times 5, so let's look at that on the calculator, okay? So, 2 times 3 times, well, we forgot a 2, we need another 3, and then a 5, okay? And that's going to wind up to be 180. 180 is going to be our common multiple for those 3 numbers, okay? And that's going to be the answer. Now, you could again have done this by listing out all the common multiples, but that would have took a very long time. So this is, again, another way or another reason why I showed you that shortcut trick, because that will save you some time, okay? There's common multiples. Hope that helped. The next video that we're going to do is multiplying fractions. So see you then.